everybody. Let me get this off here. Okay. Hope everybody's had a good Tuesday, a good week. See Wrench Sense on. How you doing? Rick, how you doing? Land's back from Tent City. You are correct, sir. That was a crazy trip out there. I'm glad I went. Don't know if I'd ever want to go back. But we had a good time out there. It's definitely a different mentality out there, that's for sure. But my youngest daughter, was her 34th birthday, and she wanted to go out, and she likes the scenery there, the big trees and the mountains and all that stuff. So she and she's a hockey fan, and her favorite team is the Seattle Kraken. So we went out there and caught a game, and they won. That was cool. And she had a whole bunch of site plans for us to do. Hey Ryan, how you doing? Good job on the bottom end of that modular motor there, getting the windage tray and pickup and tube and all that stuff done. That's a lot of fun. But yeah, while we were out there, we did the Space Needle, and we did Chaluba Glass Museum, and modern Mopop Modern Museum. Saw the Kraken game. We went to Brainbridge Island, so we took the ferry across the Sound. Went up in the Cascades and did some hiking. Kind of just did all kinds of stuff. Filled our time up there really, really quick. But glad to be home. Glad to be back in Florida. The weather's I'd much rather be in hot weather than in cold. So very happy to be back here. So got back. Shop air conditioner was broke. I had to fix that. And trying to get things moved around and things organized, and had to work on my truck. Had to do a lot of stuff around the on the shop stuff. So you got me thinking. I've got the Buick T-Type all wired up and ready to start, and it's got a glitch. So between the shop truck and the Buick and everything, and where we left off with the last wiring podcast, live show, whatever you want to call it, I decided to go one more step into that realm and talk about electronic and electrical testing. So, we've discussed how to look at a schematic, what the different symbols for your different components, relays, diodes, resistors, how they work. Figured out how to measure out, if you're going to build a harness, how to measure it out so you can build it on a table or on whatever medium you want to build it on, or build it in the car. But it's much easier to do it when it's on a board of some type, so you can lay it all out, tape it all up, or put whatever kind of looming you want to put on, stuff like that. So we did that and kind of put it all together at the end. But what happens when you have an issue? So that's kind of what I wanted to go through tonight. I kind of figured this out about 10 minutes ago. So I don't have a lot of slides to show, but I do have some stuff, so we can go into this. So I'm trying to think if there's anything else shop or oriented. The shop inspector spent a week in dog daycare. He seemed to be pretty happy when he got home. That's pretty much everything there. We got the Chevelles back in the shop. Hey John, how you doing? So we got Chuck. Hey man, how you doing? So we got the Chevelle back in the shop. We're getting ready to do some small stuff to that. I'm going to try putting some cats on. We got to try to get the dB level down on the exhaust, and we got to get some fuel smell out of it. So we're going to use a charcoal canister, universal style canister, to get the fuel vapors out. We're also going to put a flex fuel sensor in it so that we can run E85, because gasoline is made out of carbon, and carbon makes it smells. So you have a lot, you have NOx and hydrocarbons and the coming out of the exhaust, and it makes a lot of unwanted smell. So the beauty of E85 is you got 85% alcohol and only 15% carbon fuel, so it smells way nicer. I ran into that on my 50, so I always ran that car on E85 because I had pretty high compression, almost 12-to-1 compression in it, and E85 is great for that. It's very anti-detonation, so you can run timing, you can run compression or boost, and you don't have to worry about getting detonation. So long story short, I was on a long trip. I drove it to Daytona, then Orlando, and then back to Palm Beach. So I was on the road probably about 6.5, 7 hours total. And coming back from Orlando from a test session, it was pretty late at night, 11, 12, actually probably closer to 1 o'clock in the morning. And I saw a sign. I didn't have time to do any research when I was on the road. I saw on the highway a sign that said racetrack, and all your, and at least in Florida, all your newer racetrack stations all carry E85 and non-ethanol fuel. So I saw the racetrack sign on the highway sign, pulled off. Lo and behold, it was an old school station that did not have 85, and I was low on fuel, so I went ahead and put high test in it. Got back on the highway, and immediately my eyes are burning, trouble breathing because I'm getting CO2 in the carbon monoxide in the car. Never smelt that with the E85. So, right away I knew the E85 was definitely much better for that. So anyway, so we're going to be doing that to the Chevelle, get that thing going. And then this week, Friday, I have to go out of town, go over to Arcadia. I'm going to meet Leo's grandson, Will, and we're going to get some stuff done on the Mighty Mite, the Studebaker with the 4200 Atlas engine in it. We're going to go ahead, and if everything goes right on Friday, either Saturday or Sunday, we're going to get it on a hub dyno and make sure we have all those, make sure it runs good and builds boost and does all the things it's supposed to do. And then we'll see at that point, we may get a track rental on Monday and run the car. So we'll see how that all works out for you guys, how it all works out for Leo and the car, and I'll bring all the information back for next week's show. Hopefully, everything will work out good and we can go to the track and make that 7-second pass finally with that car. Leo is doing okay, but he's got some health issues that he's trying to take care of, so we're really pushing to get the car to do what he was always wanting it to do this weekend, so that we can wrap it up, and more than likely the car is probably going to end up in South Carolina with his grandson Will. So I don't know how much in the future we're going to have information on what goes on with that, but we'll see. I told Will I was, try to help him any way I can. So that's going to be that. And to get back to what we're going to talk about tonight, so I got back in town, and the shop truck is dead battery. So I had to do a parasitic drain test on the truck to figure out why it's killing the batteries. So let me get set up here. I didn't want to do that. All right, so uh, I want to get into what we need for some basic tools to do diagnostic work. So, like I said, we got our wiring harness done. It does happen occasionally. You might have a wire crossed, or a component's not working, or something, or you haven't got into wiring schematic. You're just trying to check a car. You have a car that the radio's not working, or you got a battery gets drained, or what have you. So you need a couple tools so that you can check that stuff out. So the first thing every car should have, every toolbox should have, is a test light. And this is a incandescent test light. So it's got a light bulb in it. You can hook your ground, your alligator clip to ground, and everything you touch with the probe will light up when it has voltage going to it. Now, you'd have to go by the dimness or the brightness of the light to tell how much voltage it has, but you can still do some quick testing. It's always good to have one of these in your test kit, or if you have a little tool kit that you keep in the car, just so a fuel pump dies or a fan dies, you can do a quick diagnosis, check a fuse, check the relay, and see quickly what is wrong so that you can fix it. Even if you want to do a roadkill type deal and you just wanted to power something up or whatever, this is a good way of doing that testing. A better way is to spend a little bit more money and buy a test light like this that has a voltmeter built into it. Now, depending on the different kind of meters, the nice thing is if it has a circuit board inside it like that, it's got some circuit protection. So that's always handy. Not all of these digital test lights will be able to work backwards. So when I say backwards, is you can hook this alligator clip to the positive side, and you can touch the probe to anything that's grounded, and it'll show you whether you have a ground or not. So you can test for ground or power. With this one, you definitely can do that. You can take your alligator clip, go to the positive of the battery, and you can test everything with this probe that you want to have a ground signal to, and it will light up in reverse because it doesn't know the polarity. So it will work either direction. As long as it has 12 volts and a ground on either one of the legs, it'll power up, and then that whatever you're testing. On one of these meters, some of these will not do it, so you want to check the instructions when you purchase one, or when you're looking at purchasing one, to make sure that it can do reverse polarity so that you can do testing like that. If you want to, these kind of the first type, this kind of test light, you can buy these from anywhere from $3 to $25, depending on whether you buy one from Harbor Freight or from Snap-on or any of the tool companies. So these are a little bit more money, but I would say about $10 to $50. Still a pretty affordable price range. The next one up is the power probe. Now, some people don't like these, and I'll explain to you why. But this is power probe number 2. Power probe 1 just had a red and green light on it and a buzzer, so that you would tell whether you had power or ground. It would be green for ground, red for power, and it would have a buzzer if it was a battery voltage ground or battery voltage power. Then they came out with the number 2, and on this one it actually has a voltmeter on it, and it will also have a red LED and a green LED here in the corner, so you can tell whether it's a ground or power. So real handy. These can get closer to about $100, but they're really good. And then the other nice thing about them is you have this toggle switch right here. This toggle switch, if you push the button down in the front, it sends 12 volts or battery voltage rather to this tip. So you could go to the back of a headlight that's not on, send power to it and see if it lights up. Or you could check the ground and see if it shows ground. Or you can do the same thing. If you got say you have a relay that's actuating by ground, you could pull this button down here, and it's going to send a ground signal out to this tip, and you can check, you can power or ground something to see if it works. And it's got this little push button here, so if you try to power up something that's drawing more amps than what the meter can handle, it'll pop that little circuit breaker. You let it cool off, you push it back in, and you can test again. The nice thing about these power probes is the cable is usually about 20 feet long, so you can connect it, and it has a power and ground connection, so you can connect it to the battery even if it's in the trunk and still check things under the hood. So if you want to spend a little bit of extra money, these are really good to have. And here's one step even better, and this is the Power Probe 3 or 4. And you can see on the screen here, it's got a much larger screen, and it will do AC test. You can do fuel injection test, frequency. You can read hertz. So it's like a digital volt ohm meter and a power probe all in one unit. So that's like the ultimate. These are closer to $300, but they work really good. Now, one of the things that some mechanics and some parts manufacturers don't like about the power probe is you can accidentally probe a wire, send 12 volts, and short something out. So you have to be cognizant of what you're doing with the meter, because it will send a ground or send 12 volts, and if you're connected to the wrong thing, you can ruin a module of some sort, whatever you're testing. So you just have to be very certain when you're using the power probe that you are connected to the thing you're trying to. I usually will only use the power and ground portion of this to test a motor or a light bulb or something like that, something I know it can't hurt anything. Now on this unit, on the 3 and 4, it actually has a second harness that comes off that has an alligator clip, so you can actually connect power and ground to one component and fire it without having it in the car, without any wiring to it. So you want to check a headlight, you can put the ground alligator clip on, send 12 volts to each power leg, and light the element. You can hook it to a motor, like a blower motor or a fan motor, and spin it, because you can go ground and power. So really handy to have, but you definitely have to be very careful with what you're connecting it to. The other thing that is always good to have, definitely in the shop, maybe not 100% needed in the car, is a digital volt ohm meter. Now you can get cheap ones like this at Harbor Freight for like $5. You can get a little bit better ones at Lowe's and Home Depot. They're probably anywhere from $30 to $100. This is a Fluke. This is like top of the line. This is what all your electricians, HVAC, and any mechanic that does a lot of diagnosis will use a Fluke, and these can be $200-300, but it's a way nicer, more robust meter. And this just kind of showing you what it can do. You've got voltage and AC, so like house voltage. You have DC, so all your car voltage. You can do min-max on this, so you can see the minimum, maximum. You can do current draw, which we'll get to that in a minute for doing parasitic draw test. You got a diode tester. That'll check this, make sure your diode is working. You've got an ohm meter and a continuity meter, beeper, so it does the same kind of thing. An ohm meter would measure resistance, and the continuity beep test will actually beep when you have continuity. So real nice tool to have in your arsenal, and really helpful when you're trying to do diagnostics. So if you want to check continuity, you would first of all take your two test leads, hook them together, and you should see 0.00 on your meter. That's saying it's 100% continuity. Then if you want to check a circuit, you would do something like this. Now, here's your battery, ground and plus. So if you don't want to test for ohms on something that's powered up. So here they're testing this light bulb, and it shows open, so that's saying that the light bulb is no good. If the light bulb element was good, you would then see a resistance, and it depends on how bright the light is, what the resistance would be. But let's just say 1,000 ohms, which would be 1K or 100, 1,000.0. But whatever the element, like a dash light is going to have a different resistance than a headlight's going to have. But if you check it and there's nothing, then the bulb is no good. You can do the same thing if you ohm test any kind of electrical motor. It's always going to show continuity because the windings are good. Now, if you check a blower motor or a fan motor and it has an open circuit or has a lot of resistance, then more than likely that winding may not be any good, or the brushes could be bad. So an ohm meter is good for testing that. Now, if you wanted to test this ground, you could go take this red lead, go to your ground, and then you would test all this wiring and see if there's any issues, if there's any opens in that wire. You'd have the red probe here, the black probe here, so it's checking resistance in this whole loop, anything between those two connections. One thing that I should mention, though, is if you're checking continuity without load, one strand of wire will still show continuity even if it's a 1-aught battery cable. So you have to be careful of when you're doing continuity tests, it's telling you, oh, this circuit's good. It's just saying that it does have connectivity. But to really test like a battery cable, you would have to do a voltage test. And then, that way you're seeing how, with it loaded, you can see the battery voltage going through, and that will show whether you're making continuity through the entire piece. This takes us to a battery draw test. I see Ron's in. Hey, Ron, how you doing? So when I got home from Seattle, shop truck was dead. So what you want to do when you want to do a continuity test, and this is how you can check for voltage draws. So obviously I disconnected the batteries from the truck, put battery charger on. It's a diesel, so there's two. Put voltmeters on each battery, or not voltmeters, battery chargers on both batteries. Let them charge up to a full charge. Put a tester on them. They're testing weak, but they're testing full voltage and 80% cranking amp. So on my meter, it's showing as a weak battery, not 100% perfect, but it will turn because it's still 700 cranking amps per battery. So with both of them connected, it's 1400 cranking amps. So it'll still start the truck. But I want to know why the battery went dead. So how you do that is on a single battery, you leave the positive cable connected and you take the negative cable off. You hook to your amperage. You'll see on your meter. Let me see if I can raise this, enlarge this. So you can see here's ground. So this is where you're always going to plug your ground in. But if your meter can do ohm or amperage, you'll have 3 connections for your test cables to plug in. So you've got one for ground. This one here shows volt, ohm, and that is for your volt, ohm, and connectivity, and diode testing and stuff like that. So that's where you would put your red connector. If you're going to check for amperage, you plug into the third one, and it'll be amperage, and you put your meter to amps, and now you can test amps. Now, typically, your handheld voltmeters will only be good for 10 amps. So be careful what you don't want to try to start the vehicle with the amp meter plugged in because it's going to burn it up. So let's go back here. All right, so we're going to hook our ground lead to the battery cable, which is connected to the vehicle, and we're going to connect the red one to the amperage test connector, and we're going to plug it to the battery. Now, at that point, the meter is going to show amperage of what's going through the gauge to power up the vehicle. So you want to do this with the doors shut, everything turned off, no key in the ignition, just the vehicle at rest. Now, on an old school car with points and old radio and all that stuff, that's all you have to do. It's going to show you how many amps are going through the meter, and as it shows here, if it's more than 0.05 milliohms, so that's not 1 ohm, but less than 1 ohm, then it's going to be, if it's less than 0.05, it's okay. If it's more than 0.05, you've got a draw in the vehicle. Now, because our newer vehicles, or if you've got fuel injection in your car, or you've got you got a nice stereo in the car, all those components, your decoded digital gauges, if you've got a aftermarket AC kit that has a microprocessor on it, like any of your vintage air or old air, classic auto air, all those that have a module on the board, all those have power-ups. They have keep alive memory in them. So what you want to do on a vehicle that has processors in it is you leave the connections just like you have it, but you take the negative cable, hold it against the battery for 5-6 seconds. You might even see a little arc when you do that. That's powering up all the modules in the vehicle. Once you've got it on there and you hold it on 5-10 seconds, you remove it, and then you'll see your meter turn on. You'll go from 0 to probably 1 or 2 ohms or amps, and then you'll see it in about 5 seconds, 10 seconds. It'll cut down to like 0.2 ohms, and then in another couple seconds it should drop to 0.05 or less, and that shows that there's no draws. Now, after that 60 seconds and it still hasn't gotten below 0.05, that shows that you have a draw in the car. So now what you want to do is, with everything connected just the way you have it, first thing I would do is disconnect your alternator. The alternator is a big electronic unit, and it has a little bit of a module in it for internal voltage regulator. On the newer cars, old school cars, has an external voltage regulator. You don't see those having shorts as much as your newer style alternators. So you unplug that, see if anything changes. Nothing changes, reconnect it. Then you go to your fuse box and start removing one fuse at a time. Pull it out, see if it changes, put it back in, and then go through your entire fuse box until you find where the draw is. So I did that on my truck and ended up the alternator wasn't the issue. I started going through the fuse box under the hood, and I got about halfway through it, and I found a fuse that was marked TBA, or TBC, and another one that was SEO1. So, I mean, I didn't know what those were, so I had to go to a wiring schematic. I thought the TBC was trailer brake controller, but I was wrong. Both of those actually are part of the body control module. And what a body control module is, on your newer cars, they've got a CAN bus system, and all the components, all your modules, powertrain, ABS, body control, HVAC, airbag, whatever components you have. Some cars have fuel pump modules in them. There's all kinds of different modules. So those all talk to each other. And the reason they do that is because that eliminates a lot of wiring in the car. You don't have to have redundancies in the wiring harness. It all goes through a 2-wire CAN bus and it can talk to 3 or 4 units all in one piece, and you don't have to have wires going from 20, 30 wires from each component going back and forth. Anyway, the CAN bus, or the body control module, was the problem in my truck. So I have a new one coming. Pulled those 2 fuses out, My amps reads less than 0.022, so we know we're way under the 0.05 threshold. So there is no other issues with the truck. That'll be in on Thursday, and the truck will be fixed. But so that's why I wanted to show you guys. These meters are pretty handy. You can check a lot of stuff. You can take your test light and check the back of a relay. We looked at relays. Let me go back here and pull a relay up. So here's our relay, and say this is a relay to turn a fuel pump on, a water pump on, electric fan on, your AC clutch, fog lights, anything you need powered up will probably have a relay in the car. So with a test light or a voltmeter, you can test these things. We know that this 85 is coil ground, so if it is a 12 volt switched item, your toggle switch is going to send 12 volts to the relay, then you know that this should be grounded now. So you can test it with a test light in reverse, or you can test it with a voltmeter, and you should get ground. And then same as the 86, which is your coil control wire. If you're sending 12 volts to a relay to turn a fan on or turn whatever component on, then you can turn that control on and off, and you should see it with a voltmeter or a test light. You should see it going on and off. Also, your number 30 is your common. This is what's being connected to either your fuse box or your battery or to chassis ground, depending on what you're switching. If you're switching a ground signal or if you're switching a power signal. Again, you can take your voltmeter or your test light and test to make sure that's working. And then you can also check on your terminal 87, which is your normally open. When this circuit is powered up properly, then whatever you have going to 30, which would be power or ground, should be coming out your 87. So a quick, easy way of testing to see if that relay works. Hey Chris, how you doing? So that's why I wanted to show you. So how handy a test light or a small digital volt ohm meter is to keep in your car just for that one time that something breaks down. So that's that. So then we can go on. We want to follow down the diagnostic tree. We can get to more technical stuff. That would be using a lab scope. Now, I thought I got a picture of a lab scope, but I didn't. Let me see if I can pull up a lab scope picture real quick. Okay. So this is just a quick picture I picked up. There's a bunch of different ones out there. So this is what you would get. This would be a lab scope. And what lab scopes do is they check the sine wave of whatever you're working on. So if you wanted to check a switch signal, you would go ground and then channel 1 to say a switch output, and you could switch it on and off, and you would see it going from 0 to 12 or 12 to 0 on your screen. And so what a screen would look like, nope, that's not, there we go. So this is what a lab scope screen would look like, and depending on what your triggers are, this would be your 0, and so this is a 8.49 volt trigger. So you can see it's going on, off, on, off, on, off. So this is probably like a wheel speed sensor or a crank sensor, camshaft sensor, anything like that. Something that's going to be going all the time. I don't have a wave, but if you were looking at just like a quick, you wanted to make sure something is going on and off, it would just be a straight line and then up and then straight line again. So it'd be off, up, and then on. I thought I had gotten a ignition waveform. Let me see. Let me go back here for a minute. Thought I had ignition waveform. Okay. This isn't a very good one, but if you wanted to, the other handy thing that oscilloscopes do, lab scope, is you can check your injectors. You can your opening and closing. You can check your spark plug. You can check primary and secondary wire, and you would have something. This is basically a typical spark plug. You got open circuit, the coil fires. You get this oscillation. You got this burn line. That is the dwell, the length of time the spark is happening, and then you can see the power tapers off. And all those things will show you different components. You could do a waveform, and then you could go to a library on the internet, and you could see if you had one that was, this arc here is your kV power of your coil output. So if you had one that was way down low here, but the other ones were high, you could have a bad plug wire, or you could have a spark plug that's gone bad, and and it's got high resistance in the resistor of the plug and stuff like that. So it's getting a little bit more technical with a lab scope, but they are very handy to have. And if you're going to get into diagnosing ignition problems, or you want to check cam or crank sensor on your race engine, something like that, a lab scope is the best tool for those things. You can really test everything with this. If you call a manufacturer and you're having an issue with something, they will usually ask you, did you put a lab scope on it, and what's your waveform? So that brings me to my second thing that I had to work on this week. So let me pull this up. All right, so here is one of the awesome things about a Holley HP or Dominator fuel injection system. Now, you don't get this with a Terminator, and you don't get it with a lot of other brands of electrical fuel injection, programmable fuel injection units. But the HP and the Dominator will do what they call a system log. And what the system log will do is it reads your crank and cam sync so that you can tell what's going on. So what I can do here is I'll uncheck some of this stuff. So let's see, I don't know if I can change the color. I don't know if that makes it any easier to see or not. Let me try one more time here. Yeah, it's probably the best. So what you're seeing on this screen here is we have the crank is check marked. So this is showing, well, let me get, why is that purple on there? I don't know why that's there, but if if you look down on this end, you can kind of see the line goes up, a flat line, and it goes back down. Those are the cam sensors going. That's the up signal across and back down. That's showing it's got one event. So this is giving you an event every time. So when the engine's cranking, it's going to be 8 events per revolution for 8 cylinder fires. So then we can hook up our cam, and we just have a solid yellow line here. So that's showing that the cam is not, the ECU is not seeing the cam signal is faulty, or the wiring is faulty, the pins are faulty, something of that nature. Now what the Holley will do is it sees the cam sensor, or the crank sensor, and it builds RPM up, looking for the cam sync, so it knows where to fire. There's no distributor on this engine, so it has to rely on a cam and crank signal to be able to know where number 1 is, and to start firing the injectors and the coils sequentially as the engine turns, as it rotates. So you can see here, if we put a cursor here, you can see up here in the corner where it's stall. We use the arrow. It's sinking, sinking, sinking. Never sees a good cam sync, so it never gets RPM. Go again, and it's still sinking, and never gets to RPM. So that's telling us that this is why I made the system log, because I'm watching my laptop and I see the RPM, the tachometer will say stall when the engine's not turning. You start cranking the engine and it goes to syncing as it's looking for the reading, but it never went to RPM. So I knew right away, all right, I've got an issue. We got to figure out what it is. We can go to, there's our oscillations there. So that's trying to see, the computer's trying to figure it out, but there's not, all the signal is not there. So while I'm doing this with this car, a buddy of mine calls me up, and they're having an issue with a car also. So he sent me a system log on this one. So let me get out of here. Now here we have our RPM set up. So here we're still syncing, but we can go to the next line here again. So it's at stall. There's no RPM. It sees the the crank sensor. It goes into a syncing mode. Still cranking the engine. Now you can see this is 1, 2, 3. We're on the 4th event, so the motor hasn't even turned 180 degrees yet. But as it's going through the revolutions, there was 5. There's 6. So it's almost 1 complete revolution. It sees the cam. And there we go. Boom. It says, okay, I know where we're at now. And gives us RPM, 153 RPM. And it just keeps building RPM as it goes on the starter. So that's how it works. Now how it looks on the cam crank sync side. There's our cam side. Now on this car, it's a 12-1 sensor. So if we open it up, you can actually count the pulses. So here's a gap. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then a gap because it's a 12-1. So there's 11 tooth with a gap between them. So that helps tell the computer where we're trying to put our components so that it can recognize the cranking signal, and it can verify where TDC number 1 is, so it can fire the coils and the injectors at the right time. If we add the cam sync to it, we can see here the cam sync is 0. There's our up line, goes across and back down again. So usually on a cam sync, it's only going to show where TDC 1 is, and it's usually going to be a fairly large window. So we've actually got 4 triggered events on that. So that's 120 degrees, so to speak. 30, 40, 60. Yeah, 120 degree opening at a 720 degrees. Remember, your crank turns 2 revolutions for every cam revolution. So the crank has to turn 720 degrees for the ignition to complete one complete cycle. So your cam sensor on this particular vehicle is you got 720 degrees and you got 120 degrees open. So 600 degrees of no signal and 120 degrees of signal. Now, what the issue with this is the falling was happening between the missing tooth. So it was actually 2 teeth off, and that's why this vehicle wouldn't start. So that's the reason why Holly puts these in their ECU, so you can diagnose these issues quickly and easily. Even though we went in, if we put the RPM back, when we slide over here, out here, we have RPM because the computer saw it. It just wasn't in the right location to start the engine. It was popping and misfiring like the distributor was in the wrong tooth, because essentially that's what was wrong with it. So again, I just want to show you guys how this is the same kind of signal you would see with a lab scope. It's built into the ECU. Now it's only going to show you a couple different things in the system log. It's not going to show you everything. You can see your battery voltage. That's this teal line up here. Get rid of some of this other stuff here. So it shows you, here's your battery voltage. Every time on a compression stroke, it would drop the voltage down, and then as it's filling the cylinder, the engine spins faster. You always hear the engine going whoa, 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 whoa as it's starting. Well, you can see that by the in this, because of the voltage variation. Now, here's another quick thing. If you counted this out and you had, let me bring the crank back on. So if you counted this out, see, here's your blank, and then there's 11 spikes and then an empty, 11 spikes and an empty. So if you, that would be from here to here. Let's just highlight that. From there to there is 720 degrees of crank revolution. So you could actually count 1, 2, 3, 4, 5, 6. It's 7. Well, so let me go back again. So you got 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 voltage drops during one complete 720 revolution. Well, guess what? If you had a cylinder with no compression, you would see that the volts would go straight across, or maybe be very slightly dipped comparative to the other drops. So it wouldn't be 100% telltale, but it will show where the voltage didn't drop as far in one of the cycles, and then you could verify, once you know where TDC is, you could verify with a compression gauge where that cylinder had low compression. You could actually see it with a lab scope, and you can, and there are ways, people do diagnose cylinder misfire using a lab scope through voltage, or even better yet, you can use a current probe on the battery cable and actually see the amperage change. So there's a lot of cool things you could do with a lab scope. And if you were really getting very techie with a lab scope, they have a cylinder pressure test. They will actually go in the cylinder and you can actually read compression and see the valve closing and opening on a lab scope through a pressure sensor that's made for doing that for that type of a deal. You can see all kinds of different things of how they're working electronically by using a lab scope and monitoring the waveform to see how it's working. So this is probably something a lot of you guys aren't going to get to, but I just wanted to show you, if somebody says to you, you're calling tech support and you're trying to get tech help on an electric component, and the guy says, "Oh, did you use a lab scope?" If you haven't seen this, you wouldn't know what they're actually asking you for. But a lab scope is just a voltage waveform that you can take a picture of and then send it to somebody. Whereas if you're checking it with a voltmeter, you got to watch it, and then all you can do is translate what you saw to somebody via email or unless you use a camera. But even if you took a camera, if you remember back when I was working on the Corvette, the Black Stingray, and we were having issues with that, and I was getting crazy spark patterns out of that thing, and I used my GoPro and videoed the timing light, and because of the speed of the hertz of the camera, it still did not represent exactly what I saw with my naked eye, because you've got the hertz of the timing light and the hertz of the filming of the camera, the filming frame by second, and they can mismatch each other. Where if you do a lab scope, now you've got a perfect representation. There's no deviation. Of course, if you took a screenshot, like on these lab scopes, system logs for the Holly, you can actually do a system log and send the system log to somebody to diagnose, and they see exactly what you saw. There's no deviation in camera or recording device. The lab scope is the system log is the perfect shows exactly what it's actually seeing. So very helpful. Again, it's not something that everybody's going to have because it's kind of a pricey tool. I have 2 different standalone lab scopes, kind of like the picture I showed. The problem with those are eventually they go bad and stuff, and now I've got something that's no good. So what I'm going to try to do now is they make Pico and a couple other companies make components that you can hook to your laptop, and your laptop then it's like a pass-through, and then your laptop becomes a lab scope. So this is typical, like what I have. I've got 2 different brands, but it's basically the same thing. They give you a bunch of leads and different kind of connections. I've got one that actually has a bunch of different coil hookups, so you can actually read secondary ignition. So if you're chasing an ignition misfire on a distributed car or a coil unplugged car, you can test it with that. So very helpful components. So you just this depends on the level of money you want to spend on testing equipment and how far you want to get into your testing. But it definitely is a good thing to purchase a lab scope if you're getting heavy into electronics. Like myself, I'm doing a lot of wiring, and I get a car that comes in with a misfire or something like that. You want to grab that lab scope so you can quickly diagnose it. Now, obviously, easy, cheap way of doing it. You want to diagnose a distributor car for a dead hole. You can always grab a pair of spark plug insulated pliers and pull one spark plug off at a time, and notice the variation in RPM. You'll hear it immediately. You pull a spark plug off when a cylinder is firing, you'll hear the engine start popping, and you'll hear the RPMs drop down. You find a cylinder that's not firing, and the RPM won't change at all. It may already be popping because of that cylinder. So, there are ways of doing it without a lab scope, but the lab scope is a really handy tool to get a quicker diag on what you're doing. But remember, the main thing is test lights are, I have a test light in every toolbox I have, so I probably have 10 of them. And I try to have multiple digital volt ohm meters also, because I keep one in the trailer, I keep one in my truck toolbox, I keep a couple in the shop. I got an electrical bag that I carry with me if I'm going to be on the road doing tuning, so that I can, if there's an issue, I can do a quick diag on what's going on with the vehicle and don't have to spend a lot of time trying to pinpoint what's going on. So hope that kind of sheds some light on the electrical part. So like I said, we started out part 1, 2, 3. I think it was part 4. We went through the different components, how to read the diagrams, what the electrical components, how they worked, proper tools and wiring crimping methods, and then we put it all together, and it gives you a timeline on how you want to start from either figuring out how something is working. Like if you got an AC in the car, you got a vintage air, and it's not working. Well, then you can take that vintage air wiring schematic, and then go through and find the wiring, test it, because now we know what we're looking for, powers and grounds and stuff like that. Using a test light or a digital volt ohm or a power probe, you can locate what all the wire components are supposed to be doing. When you find the one that's not doing it, then you can go back to the diagram and trace it back to, is it a bad relay? Is it a bad pressure switch? Is it a fuse? Things like that. Same thing with your cooling fans. Is a sensor, you have a temp sensor that's sending a signal to a relay to activate the fan, or is it coming from an ECU or a toggle switch? And then you can go through and systematically test the components to figure out what's wrong. So instead of having an issue where you're not sure what's wrong, now you have a roadmap of how to go about trying to figure it out. It's real handy. You're driving down the road. Chris had this issue at one time. The car just shut off. The fuel pump just quit out of the blue. And now what do? If you don't have a simple test light, you can quickly figure out what's going on and come up with a remedy. In his case, a bad connection, a wire connector had came apart, put it back together, fuel pump turned back on, back driving again. So that's what I wanted to show this stuff, because I know electrical for most people is kind of not a black magic, but it's kind of a maybe you know it, but you don't know it kind of thing. But the good thing is most everything in an automotive car is DC voltage, direct voltage. So you got grounds and you got power, and it's not you don't have open legs and the other things you would have, like with house or building electrical, where it's AC voltage and you've got commons, you've got grounds, you've got 2 different 110 legs. That's a whole Ryan says witchcraft. Yeah, so the AC stuff is a lot more complicated, but luckily for us, most things in the cars are DC. You'll get in the AC with magnetic triggers, like in an MSD ignition trigger, MSD distributor. That's a magnetic trigger, so that's going to be an AC wave. Anything that's a speed measuring device that's 2 wires is typically a AC wave, so that becomes a little bit trickier, and that's where you need a lab scope so you can watch that waveform to know what's going on. But most everything else, a simple test light, you can kind of figure it out. A digital volt ohm meter or a power probe, you can even check it out, figure it out even faster, and get off the side of the road and get driving down the road again. So really helps out to just kind of understand this stuff. Hopefully you guys got it. If you don't, leave something in the comments. Let me know, and I'll try to go over it better. This was thrown together very last minute. I was talking to JB, driver of the Smurf, at 6:25, and he says, "What are you going to talk about tonight?" And I said, "I don't know." I said, "I got to go. I'll talk to you later. I got to figure it out." So, yeah, it won't diagnosing the wife. That is very, very, very sure you cannot do that. she's neither AC nor DC. I don't know what kind of waveforms they're going to make, but I know they're very complicated. But at least our cars, we can figure them out and get them moving. So again, I just want to get this so you guys can kind of not be so scared of electrical problems. The only thing that can still cause a serious electrical gremlin is that intermittent component, and those are a little bit more complicated. But that's where a lab scope comes in handy, because now you can connect it to that component and drive it and get a screenshot of when it fails, and then kind of help diagnose it. So the wives need OBD, you're right. We need a diagnostic plug-in port for sure. Well, I hope this work was good for you guys. Let me know if you need any farther stuff on electrical. Hopefully next week we'll have some 4200 Atlas race engine stuff to go over, and hopefully maybe even have a couple. We'll definitely have some dyno runs to look at, and maybe hopefully even maybe some hits at the racetrack. So we'll see how that goes for next week. So I think with this, we're going to go ahead and pull the plug on tonight. Remember, smash the like button. We're almost got 8,000 likes on the channel, so that was really good. Appreciate that. Subscribe. It's free for you guys that haven't subscribed. Ring the bell. You'll get instant notification. Again, all that stuff. You're not going to get any spam in your mailbox or anything like that. Nobody's going to contact you, so don't worry about that. Subscribing to your favorite YouTube channels, whether it's me or anybody else, helps them out, and it basically you're paying them back for being able to go and watch their stuff. So think about it. Subscribe, share to your friends. Turn your friends on to your favorite channels so they can see what's going on, learn some stuff, be entertained, watch some racing or whatever the channel is all about. So with that, we'll go ahead and pull the plug. Appreciate it, and we'll see you guys all next week. See ya.